Hello and welcome to Byju's Exam Prep. Welcome to this video where we shall be talking about our universe. Now, this is one of those topics in your syllabus for civil services where we end up covering this both in the topic of geography as well as in the portion of science and technology. So, while in the portion of geography, we shall be covering the basics regarding what do we mean by our universe, what are the various and major prevalent theories regarding the origin of universe that we have to know about, what is Big Bang theory that you hear about, and also the properties of various different components in that universe. For example, the solar system, for example, the properties regarding the sun, planet Earth. How is it that the planet Earth would have been created? How is it that moon would have been created? And also various different aspects regarding what are coronal mass ejections, what is Milankovitch cycle, what are the Goldilocks zone. All those technical parameters and technical terminologies shall be covered in this portion of geography. Now, when we talk about our universe, we basically talk about anything and everything which surrounds us. Now, the curiosity to know about the universe is something which is not new. Mankind, in fact, has always been intrigued by the world which surrounds our planet. Even if you take a look at certain prehistoric cave paintings, there also, in those cave paintings, you will find certain celestial objects being painted, which tells you again the same thing, that our curiosity is not new. Man has always wondered about the various different objects that have always been spotted in the night sky. Mankind has wondered why is it that sun rises in a particular position and sets in a particular position. Thousands of years ago, our belief was very simple, that the entirety of the planet is flat and basically sun keeps on moving around the planet. Now this was a kind of a model of universe which was referred to as a geocentric model. And when we talk about a geocentric model, what does that depict? Geocentric. Here, geo refers to Earth. So, this model talked about the aspect that Earth is present at the center of the universe and the entire universe keeps on moving around the Earth. But then, slowly and steadily, as our understanding about the celestial objects increased, and as slowly and steadily we got to know more about the properties of the sun, the moon, etc., then, after that, in the 1600s and roughly around 1700s as well, the world came up with a model which was referred to as a heliocentric model. Now, what was this heliocentric model? This heliocentric model basically told us that sun was present at the center of the universe and the entire universe moved around the sun. There have been various different customs and traditions, even in ancient civilizations, where sun has always been worshipped as a god. And thereby, sun was always provided a kind of a reverential position. And with that aspect came the theory that sun would be the center of universe. It is only today, after significant amount of scientific breakthrough and discoveries, that we know that neither the earth nor the sun is present at the center of the universe. Now we know that we have not even explored the entirety of the universe. Whatever study that we carried out and whatever various theories and postulations that we put forward, all of that is done for the observable universe. And this is a terminology that you have to understand. So, whatever theories that you will study, whatever fundamentals that you will study, that will be about observable universe. Means what? It means that there is a significant portion of universe that we have not yet explored. We know very little about it. Slowly and steadily, the frontiers of science are increasing from all different directions, and slowly and steadily, we make ourselves much more aware about what is going on around us. How is it that the universe would have come into existence? So that is why, even when we take a look at the various different theories which postulate about the origin of universe, you will find that the earlier theories provided during the 1700s, they talked about universe in the aspect of solar system. For them, the solar system constituted the entirety of the universe because that was the limit of scientific exploration at that point of time. In the 20th century, when our understanding increased, that is when we started looking for other stars as well. And that is when we started looking for galaxies which are away from our own galaxy. So that is how, when we talk about observable universe, it is very aptly put and aptly described in a form of a kind of an analogy that if we consider the entirety of the universe, all the galaxies, all the stars, all the various planets taken together, that observable universe will occupy a kind of a disk of, let's say, diameter of around 8 inches. That is how much we have explored. And just to know the extent of it, the entirety of the universe is estimated to be a larger area, a very large portion, having a radius of around 97 kilometers. This is just the scale of it. This does not mean that the universe is confined within 97 kilometers. This just tells you that all this discovery, all that scientific discovery about stars millions and billions of kilometers and light years away from us, all those that we have looked at, that we have discovered, all those are confined in this small space in the entirety of the universe. That tells you how humongous this universe is, and that tells you how much more is left to be explored. So, with the passage of time, one thing which is certain is that 10 years from now, or even 5 years from now, considering the rate at which scientific discoveries are being made, from 5 years from now, you would be expecting many new theories regarding the origin of our planets, regarding the origin of the universe in general, and also various different properties about it. Think about it, how much area of universe is still left to be unexplored. So when we talk about our universe, here, first of all, we have to understand the scale of it. So initially, when we talk about, let's say, the universe in itself is made up of multiple different components. The smallest components amongst all of them are the stars, the planets, the moons, asteroids, meteorites, all these different celestial objects that we see around us. When we say the case of stars, take the case, for example, sun. Sun is a star, and sun is the star which provides energy to all the planets which move in their orbits around the sun. So all that, including the planets, including the other stars, including the moons of various different planets, the asteroids, the comets, the meteors and meteorites which fall on the surface of various different planets, all these, they are the smallest constituents in the entire makeup which we refer to as the universe. Then after that, you have the portion, if you consider, you have the portion of when multiple different such stars and planets come together, then you have establishment of what we refer to as a solar system. So a sun or a star and its planets, sun and the planets which move around it, all of those, they make up the solar system. Now this solar system is the system of the sun, planets and the moons around them. So we can have an infinitesimal number of stars across the entirety of the universe, and each of these stars will have their own individual groups of planets which are in existence. All these will make up their own solar system or the own star system as we refer to. Multiple of these stars, thousands and millions and billions of these stars, they form a cluster of stars which we refer to as galaxy. So a galaxy is made up of multiple of these stars and millions of these stars considered together. Each of these stars will have their own set of planets. Each of these planets will have their own sets of moons. And in each of these systems, you will have huge number of asteroids, comets, meteorites, etc., which will be present. Many thousands and millions and billions of galaxies, when they are combined together, that is what constitutes our universe. So think about it, how small we are. This gives you an idea and the perspective into the entirety of the window around us. So when we talk about our universe, let us not think that we are one of the important constituents of universe. Because after all, in the universe, you have one such galaxy out of the millions, that is the Milky Way galaxy. That is our galaxy. Milky Way galaxy. Now, in this Milky Way galaxy, Sun is amongst one of those millions and billions of stars which keeps on moving around the Milky Way galaxy. Sun is not even at the center of Milky Way galaxy. It is just one amongst many. Now, in that region where you have the sun which is present, around that, again, you have various different bodies that we refer to as planets, which keep on revolving around the sun. And amongst many of those planets, you have our very own blue planet that we refer to as the planet Earth. So think about it, how small we are in the entirety of the universe. And this again is a part of observable universe. There is still much more that we have not yet explored even. Now, once we are aware of this hierarchy of setup, so to say, then let us move forward and let us take a look into what we consider to be the origin of our solar system. Now, as we have talked about it before as well, that initially when the scientific discoveries were not happening at an increased pace, and basically our scientific knowledge and understanding was also restricted, the idea was that planet Earth is at the center and the entirety of universe moves around it, which then was proved to be incorrect. Then came the heliocentric model, where the sun was supposed to be the center of the universe and the entire universe moved around it. So the earlier theorists who provided their theory regarding the origin of universe, they were basically Immanuel Kant, and he provided his theory regarding the origin of universe way back in 1765. Then his theory prevailed for close to around 30 years. In around 1796, you had another one of the physicists with the name of Pierre-Simon Laplace. Pierre-Simon Laplace. Now, when we talk about discoveries and the theories postulated by both Immanuel Kant as well as the theory postulated by Laplace, for both of them, the solar system in itself meant the entirety of the universe, because the threshold of scientific discovery was very, very limited up till that point of time. So when we talk about our solar system, initially, the solar system basically constitutes of the part that is the sun, and around it, the planets which keep on moving around the sun. So we have the closest planet situated very close to the sun, that is the planet of Mercury. Then we have Venus. Then we have Earth. Then we have Mars. Now, all these four planets, they are also what are referred to as the terrestrial planets. These are referred to as the terrestrial planets. Why? That is because they have a significantly larger chunk of the surface which is very, very solid. That is why the terrestrial planets name is ascribed to them. Now, beyond Mars, you have an entire belt where you have large chunks and large bodies which keep on moving around the sun in an orbital plane, and that is what we refer to as asteroids. And that entire zone, that is referred to as the asteroid belt. Now, here, these asteroids, they get influenced not only by the gravitational pull of attraction of the sun, but also simultaneously by the gravitational pull of attraction of the next major system around them, that is the gas giant of Jupiter. Jupiter is one of the largest planets across our solar system. Now, when we consider the planets such as Jupiter, then you have Saturn, then you have Uranus, and then you have Neptune. All these four, they are significantly larger in size as compared to the terrestrial planets. And that is why these are also referred to as gas giants. These are basically made up of gaseous substrate. And that is why the name gas giants. And because they are very far away from the sun, so that is why they have taken slightly larger amount of time to form the systems around them, and that is why their size is also particularly larger. Now, for a long period of time, as we have already talked about it repeatedly, our understanding of the universe was restricted only up till this. In fact, up till quite recently, we even considered Pluto as another planet. But then, in the past couple of decades, our understanding has further improved, whereby we now know that Pluto is no longer a planet. So now we have only 8 planets in our solar system. Earlier, we used to consider 9 different planets in the solar system, with Pluto being the farthest away from the sun. But now Pluto has been, in fact, in a way, kind of delegated, or in a way put down from the category of planets as any other celestial object. Now, here we shall be taking a look at the 4 different theories which are prevalent in terms of establishing a kind of a theory regarding the formation of the universe. So it all started with the gaseous hypothesis of Kant. As I told you, it was conceptualized way back in the 1700s, that is 1765. Then in the era around 1796 came the nebular hypothesis of Laplace, which was nothing but a slight modification from the theory of Kant. That again prevailed for roughly around 100 years. It was only in the 20th century when you had various different astronomers and various different physicists such as Jeffreys, Chamberlain, etc., and they put forward their own different theories of collision regarding the origin of universe. But for general studies purposes, you are not required to learn or know about those theories as well, because those theories, in a way, they don't justify the formation of our universe. The theory which completely helps us understand, as per our present scientific discovery, the theory which stands the test of time and which explains the formation of the universe, is the Big Bang hypothesis. That is again something we shall be looking at. Other than that, we shall also be taking a look at the accretion model of formation. This accretion model of formation, this helps us understand the formation of various different planets. So how is it that the planets got created? That is something which is explained aptly well by this accretion model. So that is the various different theories that we shall be taking a look at. So we shall be starting with the first theory, that is the gaseous hypothesis of Kant. Now, when we talk about the gaseous hypothesis of Kant, here we have to understand that Kant assumed certain things and certain things to be in existence, and thereby he postulated that how the solar system would have come into existence. So for all practical purposes, this hypothesis of Kant, it deals with the theory regarding the origin of universe, or regarding the origin of the solar system. Because at that point of time, the solar system was the entire universe for us. We did not know there does exist various different galaxies as well. Now, this hypothesis very quickly, or rather not very quickly, but over a span of 100 years, this was completely debunked. But then at that point of time, for close to around 100 and 150 years, this was one of the most prevalent theories. So let us try to understand what this theory does talk about. When we talk about this gaseous hypothesis, so here the aspect was that there did exist in the universe from earlier itself, there was the existence of a kind of a nebular cloud. When we talk about a nebular cloud or a nebula, what do we mean by that? So, nebula refers to a combination of various different types of gases, dust particles, ice crystals, etc. So, Kant assumed the fact that there was in existence a nebular cloud. A nebular cloud consisting of various different small particles, small different masses which were already in existence. Now, each of these individual particles, as per Kant, and which was also true to some extent, when you have multiple different particles which are in existence, each of them will attract each other. Why? Because of the force of gravitation. So, because of the force of gravitation, these different objects would start attracting each other. And when they would attract each other, Kant said that that would lead to significant amount of collision. And collision resulted in a generation of heat. Whenever multiple different particles would exist, all of them would start colliding with each other. And because of millions and billions and trillions of such collisions happening simultaneously, there would be enormous amount of heat which would be produced, and all that primordial matter that would get converted from a solid state to a gaseous state. And that is what would explain the gaseous state that the nebula used to exist in. Now, after that, he said that large particles in the primordial matter were scattered in the entirety of the universe. And that was scattered around. Why they were scattered around, in what order were they scattered around, that is something that Kant did not specify. In fact, he went ahead and said that these collisions, when multiple objects they started colliding with each other, that induced a kind of a rotational spin amongst all those solid materials, and the nebula in itself that started rotating around the central mass. So he said that they started colliding against each other due to the gravitational pull of attraction, and due to multiple of these collisions, they started, or the entirety of the nebula itself, that started rotating around its axis, creating a bulge around the center of that orbiting plane. Now, that bulge, as per Kant, was the present day sun. And around it, multiple different objects, they started rotating around. Now, first of all, do we exactly know that collision leads to a kind of a rotational motion? No, it does not. But then Kant, you cannot fault him because he was neither a physicist nor a mathematician. So for him, this was a kind of a postulation where he did not dig much deeper into it. But then again, we are talking about the era of the 1700s, where still many parts of the world, they did not have an idea about the sun, the moon, and the various different planets. So that is why hindsight is always a good teacher, but then we should not judge the theory which was postulated 300 to 400 years back. Having said that, he then said that when this bulge increased in size, there were multiple different rings which started forming one by one and were separated from the middle part of the nebula. And why did this happen? Because, as per Kant, all this was already in a rotating motion. The nebula was already moving around the central bulge in a kind of a rotatory motion. And this rotatory motion meant that there was a force acting away from the center. What was this force? This was the centrifugal force. Centrifugal force. Now, because of that centrifugal force, the rings, they started separating from each other, and the masses in those rings, they condensed and they came together to form the various different planets that we know of. So again, look at it. This was a theory regarding the origin of universe. But what have we talked about exactly? The solar system. That was our understanding at that point of time. Now, his theory had a basic kind of postulation that the central mass, which was left over after the rings got separated, that became the sun, and the rest of the rings, they became the various different planets that we know of. Now, his theory was laced with various different types of postulations regarding the formation of moons as well. Because by the year 1700s, we had already developed a telescope. And with that telescope, we had been able to notice that there does exist various different moons for other planets as well. So thereby, the formation of the moon was also postulated on a similar lines by saying that repetition of the same process which happened across the level of the solar system, that same process got repeated at a much smaller level, and you had the formation of moon around the planet by that same centrifugal force of action where the rings of matter could get separated. And then rings were separated from the newly formed planets, and materials of each ring condensed to form satellites of the concerned planets that we refer to as the moons of these planets. Now, his theory was laced with various different drawbacks. The first major drawback was that he did not explain the source of this primordial matter which created that nebula. He could not explain that. He did not even think about what could be the condition which would have led to the existence of such large scale dispersed materials to come into existence in the first place. Then, after that, he did not explain the source of energy which would lead to the collision of particles. Why is it that the particles, when they were existing in a primordial state, why would they begin the collision in the first place? After that, he also could not explain that why is it that collision of particles would lead to a kind of a circular motion. Because when two particles collide, rarely do we observe those particles to spin around each other, and rarely do we observe them to go around in a circular motion. So that is where his theory was defeated, and his theory was then debunked. But then a modification was carried out in the year 1796 by Pierre-Simon Laplace, and he put forward the theory that we refer to as the nebular hypothesis. Now let us take a look at what this nebular hypothesis was. Again, we are still in the 1700s, so the level of discovery was not very significant, and Laplace again was concerned only with the solar system. So as per Laplace, the theory was basically just a kind of a modified version of the Kahn's hypothesis, and as per Laplace, there was in existence a hot and a huge gaseous nebula, and that was already present. He said that, look, let us not think about that where did that gaseous nebula come from. He did not talk about the primordial matter that Kant concerned himself with. In fact, in this entire theory, nowhere will you find the mention of the primordial matter. He straight away jumped to the existence of a nebula. That let us assume that there was this state of gaseous matter, dust particles, ice crystals, etc., which were already in existence, that was hot. And basically, this was the nebula that was in existence. Now, thereby, he solved the problem of the various different aspects of nebula through this basic assumption that let us assume this was already in existence. Now, from the very beginning, the huge and hot nebula was rotating around its axis. So again, he did not have to explain that why is it that the nebula was rotating around the axis. He simply assumed that as well. Now, after that, he went a step further, and basically he said that it was continuously rotating around its axis along a kind of an axial plane, right? So it was not a kind of a three-dimensional postulation that he gave. It was a kind of a two-dimensional postulation that nebula was rotating around its axis in a kind of an orbital plane already. Then after that, nebula continuously was losing heat from the central portion. The central portion would emit lot of radiation, and through that radiation, heat was lost into the outer space. Now, thereby, nebula was losing heat from its outer surface due to the process of radiation and was thus reducing in size and volume due to contraction. The central portion was getting restricted and reduced in size. Observe the central portion as per the artistic recreation of his hypothesis, the central portion was getting reduced in size. Now, by the law of physics, one of the laws of physics, that is the conservation of angular momentum. Those of you who are not aware about that law, don't worry about it. Basically, it talks about the aspect that when any rotating object, its size or its perimeter or circumference basically reduces, the speed of rotation increases in order to conserve the angular momentum. Think about it. When you see in your television sets or when you see outside a person skateboarding, now you would observe that people skate on ice, right? Ice rings which are made out. Now on those ice rings, when people they start rotating with their arms spread out, they would rotate in a kind of a speed, angular speed. But when they hold their arms inside or when they reduce their entire dimension, their speed of rotation significantly increases. That is the property of the conservation of angular momentum that Laplace used. And as per that hypothesis or as per that principle, as the size reduced, the velocity of rotatory motion that began to increase. Again, the principle of conservation of angular momentum. Now, the speed increased. As the speed of rotation would increase, so would what happen? It would significantly increase the centrifugal force as well. And when we say the increase in centrifugal force, this is a force acting away from the center. So thereby, with increased velocity, the rings they started detaching. So one similar aspect from Kant was the fact that he also talked about the detachment of the rings from the central portion. But then he said that this detachment happened because of sudden increase in velocity, because of which the outer part of the nebula could no longer rotate at the same speed as the inner portion. So think about a larger disk which is rotating, but somehow you manage to create a condition where the inner portion of the disk is rotating at much greater and a much higher speed. So when that inner portion is rotating at a much higher speed, then obviously the outer portion of it will get disconnected. And by that process, he said that there were creation of many such rings, which we nowadays observe in the form of different planets in existence. So he said that each ring condensed at a point in the form of gaseous mass, which started rotating around the nebula. And eventually, it is these masses which made up of the planets that we see now, because the gaseous matter later cooled down and eventually formed the planets. And the remaining part of nebula at the central portion, that is the central portion, the remaining part of nebula in the central position, that is what formed the present day sun. So that was the theory provided by Laplace. So initially you had that hot nebula which was rotating slowly and steadily. As it started losing heat, the central portion started condensing. The central portion started becoming smaller and smaller. When the central portion started becoming smaller, the speed of rotation significantly increased. With that increased speed of rotation, the outer extent of the nebula could no longer keep pace with the movement of the internal portion, and that is when they started disconnecting themselves, disjoining themselves, and that is how you had creation of multiple rings. And these gaseous materials, they then condensed to form the various different planets. Now, if you take a look at both these comparatively, you'll find much of a similarity in both these theories and both these hypotheses. So, his hypothesis was also laced with huge number of limitations and huge amount of drawbacks. So the limitations of Laplace theory were he did not explain the source of origin of nebula. He said that nebula was rotating, but where did the nebula come from? And how is it that a rotational motion was induced in that nebula? That is again something that he completely avoided. Then, if the planets have been formed from the rotating nebula, then the residual part of the nebula, that is the sun, should rotate at the highest speed because of the conservation of angular momentum. But that is not the case. The sun does rotate around its axis, but it is not rotating faster than the planets around it. So there again, simply by the laws of physics as well, his theory was defeated. Now, if you are finding these theories to be slightly absurd and you are finding these theories to be slightly more difficult to comprehend, don't worry about it because these theories have been debunked. So these theories, because of huge amount of limitations, they have been debunked. And all those aspects of these theories which do not make sense to you, all those precisely will form the drawbacks or the limitations of these theories. Now then we come to the third major theory in that regard, and that is the accretion model of formation. So when we talk about the accretion model, what do we mean by the term accretion? Accretion refers to a kind of accumulation of various different materials into one giant mass. That is accretion. Accretion can be observed in your surroundings as well, right? So for example, you see, let's say at the floor or underneath your bed, you will observe many different dust particles. They will accrete various different particles amongst them and form a kind of a larger dust bunny of sorts. So that is where materials, they start sticking to each other. That is the basic form of accretion. So without going into significant amount of depth regarding what are the fundamental principles around accretion, this accretion model, why do we study this, is basically it helps us understand the process of formation of planet Earth. So when we talk about the accretion model, it talks about the aspect that yes, there was a nebula which did consist of gases, dust particles, as well as ice crystals. Now, this nebula had these dust grains, and these dust grains, they would come together. Golf ball sized dust grains. All of you would have seen the size of a golf ball, right? The ball with which you play golf, in simple terms. So, that golf ball sized particles were present in the entirety of the universe. Now, they started coming together slowly and steadily. When they came together, they collided, and the heat produced due to this collision was enough to weld them together and to form a larger mass. So think about two small particles. When they would come together, basically they would form a larger mass, and that larger mass would then attract another small particle and it would form a further larger mass. So this process repeated itself multiple millions of times, and that led to creation of larger boulders. Many of these boulders then started colliding and they formed the initial part of the planets, or what we refer to as planetesimals. That is very large chunks. Multiple of these planetesimals, they came together, they collided together, they stuck around because of the heat produced, and that is what gave rise to the planets that we see around us. So this was the aspect which told us that how the planets got created. What were the various different stages involved in the formation and the creation of these planets. So observe this. Here, around the central star, in this case we will observe or assume the central star to be the sun. Around that central star, in that orbiting plane, you had multiple and millions and billions of dust particles which were moving around the central star due to the force of gravity pulled by the central star. Now these dust particles, they started colliding, they formed larger boulders. These boulders, they formed small planetesimals, they collided with each other to form planets. So planetesimals, they grow, moving in near planar orbits or in the same plane, and they formed the embryos of the planets that we see. Now, then these planets then started moving around the sun along the fixed orbits where they were created. The gas giant planets, they accrete gases which were present in the outer extremities around the sun, and those gases, they started condensing and they started accreting around a central point, creating larger gas giants. So this accretion model explains beautifully well that how various different systems came together to form the planets that we see around us. So basically, it also talks about the aspect of these gas giants and how they were created. And that is a different matter as compared to the theory which was postulated by both Kant as well as Laplace, because neither of them talked about the formation of gas giants. Both of them, they talked about only the aspect of the entirety of the solar system. This accretion model talks about that, yes, because in the solar system, the closer that you go to the sun, greater will be the gravitational pull of attraction. So solid particles would come much closer to the sun. That is why closer to the sun, you find solid planets in existence that we refer to as the terrestrial planets. Whereas as you move slightly farther away from the sun, gases would be left behind. But then these gases, they are also constituted of atoms and molecules. Those atoms and molecules would pull each other together. And that is how the gases also came together to form larger masses that we refer to as the gas giants. That is why these gas giants, they are much larger in size as compared to the terrestrial planets in existence. Now, in the 20th century, when our understanding increased quite significantly and sufficiently regarding the existence of various different stars and galaxies around us, that is when the most acceptable theory regarding the origin of universe was floated in the 1920 itself, and that was basically referred to as the Big Bang hypothesis. Now, when we talk about the Big Bang hypothesis, this Big Bang hypothesis was provided in the early phases of the 20th century. So it was Georges Lemaitre who first suggested the aspect of Big Bang theory in the 1920s itself. Now, his theory was very simple, and his theory was based on certain calculations. The calculations and observations were that all the various different objects in the universe, all the various celestial objects, they are continuously moving away from each other. Please understand, the observation was that all the celestial objects, they are continuously moving away from each other. It is not as if they are moving towards any other celestial object. It is not as if all of them are being attracted by someone else. No, all of them independently are moving away from each other. So he basically thought that if all of them are moving away from each other right now, means going back in history at one point of time, all of them would have been together. And from that, there would have been an explosion so powerful that would have led to creation of such hot gases, etc., which would move away from each other, and later on these gases would condense to form solid particles. These solid particles would then form the various stars, and these stars would have led to the creation of various planets. So the Big Bang theory, in simplest of terms, that talks about the existence of a kind of a singular object, and that singular object would have undergone so much high amount of pressure and temperature that there would have been a huge explosion. It is estimated that the Big Bang or the explosion would have happened close to around 15 billion years before present. And at around that point of time, that explosion would have been so large that till today, the objects are moving away from each other. So that was in a crux the Big Bang theory. Now, basically, he theorized that the universe began from a single primordial atom. So a single atom would have been in existence. Now, the idea that was postulated, As I told you, that idea was then validated with the help of various different scientific observations made by astronomers of that point of time. And one of the leading astronomers of that point of time was Edwin Hubble. Edwin Hubble had devised a very powerful telescope. And based upon the studies and observations carried from that telescope, Edwin Hubble postulated a theory which was referred to as the theory of expanding universe. It was the theory of expanding universe. That was the theory put forward by Edwin Hubble. Now, Edwin Hubble said that look, all the various different galaxies are speeding away from us in all different directions. And this was an observation, again, something that he made in the 1920s itself. Now, this was later validated by the scientific studies done during the duration of 50s, 60s as well, where the discovery of cosmic microwave radiation that was interpreted as the echo which still existed as a result of that Big Bang explosion which happened billions of years ago. So those various different radiation and cosmic waves which were studied, they gave us a clearer idea that yes, indeed, at one point of time in history, there would have been such a major explosion, such a major bang, which would have created the universe in existence. And hence the name, the Big Bang. Now, theory was finally validated as late as 1972, and it is still something which is accepted world over. Now, as per this theory, again, take a look at the schematic representation. The entirety of the universe was basically condensed in one small primordial matter. That small primordial matter would have underwent a major explosion. Why? Because at this point of time, the temperature and pressure which would have been experienced by this primordial matter would be very, very high. And because of that high condition of temperature and pressure, there would have been that explosion due to which slowly and steadily the materials they started moving away from each other. As they moved away, the temperature reduced. That is when they started condensing to form stars, planets, celestial objects, galaxies, etc. And that is where today, if you will observe, we are still in a phase where the objects are moving further away. Now, here, all matter in the universe existed in the form of dense and huge primordial matter. This is the singular point. Singular material, or the singularity as it is sometimes referred to as. Singular material, which would have experienced very high temperature and pressure conditions. Then after that, a violent explosion took place in this primordial matter itself. And this violent explosion, what did it do? It basically, the dust particles present in this matter were scattered and they are still moving significantly away. Over several million years, slightly denser regions become gravitationally attracted to each other because they will have certain mass, they will pull other material which also has certain mass. Now, they grow even denser, forming gas clouds, stars, galaxies, and other celestial objects that we see around us. Now, here, this theory was proven by various different postulations, by various different observations. One of those observations was done by Hubble. Edwin Hubble, in a way, was one of those people in the sense that they have left their mark in the astronomical community to such an extent that the studies carried out by Hubble still stands valid today. That is why before the James Webb telescope that you see now orbiting around the planet and now taking the observations of the universe, before that, the largest telescope in existence orbiting for very long period of time was named as the Hubble telescope. That was the stature of this man. Now, this astronomer Hubble discovered that the universe was not static, rather, it was expanding. And it was expanding because the objects were moving away. And this was the theory of expanding universe. UPSC has asked a question about this in the prelims. And this was a kind of a multiple choice question where UPSC had asked that which of these people provided the theory of expanding universe, and the correct option was Edwin Hubble. Okay. Now, here he also came across the aspect that we refer to as the red shift. Now, what was this red shift? So basically, we know that light is emitted in various different wavelengths and various different spectrums as well. So basically, when we observe light being emitted, as you would have studied in your class 10th level science, that light is emitted in various different spectrum, and that is represented by VIBGYOR, right? Each of them, they stand for different color or different wavelengths of light. So you have violet, you have indigo for I, blue for B, green for G, yellow for Y, orange for O, and R for red, right? So that is the wavelength in which light is emitted, which helps us look at various things in different colors as well. So redshift is an increase in the wavelength of light. When the wavelength of light is significantly larger, what is a wavelength? So light travels in the form something like this. So this is referred to as the wavelength. Okay, the length of the wave, that is represented by the Greek term lambda. Now, here redshift occurs when the radiation travels between the objects which themselves are not static. So let us suppose you have an object that is, let's say, sun, and we are a person standing millions of kilometers and millions of miles away from the sun. Now, the light emitted from the sun would be received by us in various different wavelengths. If the sun in itself, let's say, started moving away from us, that means the energy of that light would also reduce. When the energy of light is very, very high, at that point of time, light is transmitted in the form of short waves. When the energy of light is particularly low, it is transmitted in longer wavelengths that we refer to as long waves. And these longer wavelengths, they give a reddish appearance. So when, let's say, the sun is moving away from us, or any light emitting object is moving away from us, longer wavelengths would be received by us. And that is when redshift occurs. So radiation travels through the expanding space, and that radiation is caught by us in the form of redshift. Now, Hubble measured the redshifts of a number of various distant galaxies around us. By this point of time, we were fully aware that sun is not the only star in the universe, and ours is not the only galaxy which is present around the universe. Now, when he plotted these redshifts against the relative distance of these galaxies, thereby he found that the distant galaxies, there the redshift increased as a linear function or their distance. That means that as the distance increased, the redshift also increased, which told him that basically the galaxies, while they are emitting those wavelengths, they are still moving further away. And that is the basis on which he postulated the theory of expanding universe. Now, this theory was then utilized in order to postulate or prove the theory which was provided by Big Bang, that is, everything is continuously moving away. Now, Hubble's law, galaxies are moving away from Earth at a speed proportional to their distance. That is, the ones which are farther away, we are observing a greater redshift because obviously the distance is also going to change. So that is the theory of expanding universe as well.